on the next presenter. His name is Aditya Vasekar. Aditya is also a good friend of mine, and he's also from Pune. And Aditya's expertise in the architecture, Azure architecture, and Azure and the uh, AWS are now getting utilized by or getting utilized in the uh, IoT environment. And his responsibility is to make sure that these environment gets secured through those uh, cloud actually. So if someone get cloud get compromised, he or she can do anything actually. He or she can control the entire IoT device. So IoT device can be your telematics in the vehicle. It can be anything, any appliance actually in this case. So yes, thank you so much, Aditya, for coming here and for your wonderful time over here. So please, over to you.
Hey, thanks. Let me share my screen. Let me know if you guys are able to see. Am I audible? Is it okay? Can you guys see the screen? Okay.
Yes, yes,
Visible.
yes. It's
Okay,
visible.
great.
Yeah.
Okay. So yeah, thanks Arun. Thanks for the wonderful introduction, I would say. And yeah, the today's topic were kind of very interesting. As on toes for whatever the discussion happened till now. Uh, Starting with Paul, then Surmeet and yours. So I'm sure I'm not going to bore you guys because most of the session what I have is like might be um, built as a beginner because this is like a three-part series what I'm trying to establish here. So this is related to the Azure IoT at every layer. We will try to go and see how exactly the IoT devices will be getting connected to the Azure environment, and what are the basic fundamentals, at least, when we look at the from the Azure side, okay, what needs to be taken care from the security point of view, how what are the different layers where different attacks might happen and how we can secure them. Okay, so first part is about uh, this is just a starting beginning, how the connections happen, what are the different layers, what are the different possible attacks, and if someone is very much new to this environment, and if you are into this environment, if you see some of the issues today, maybe you can prioritize them accordingly. After this session you should be able to do it. Okay, that would be the takeaway. So this session is again designed very beginner friendly. You don't need any prior IoT or security experience. We'll cover how Azure IoT works, what the three core security pillars are, what the top five mistakes teams make in production deployment, and build in Azure tools uh, you can start using today. Okay. So okay, let's start. Uh, Before that, I'll just share my background. I'm currently working with Microsoft as a product security manager. Mostly, I revolve around the architectural design, providing solutions, securing them for the um, healthcare domain. There are a lot of Microsoft design applications, products, different industries are using. We try to help them with that. Okay, so I mean, with the today's today's different talks, I think most of you are already aware what is IoT and why it's everywhere, right? So, um, currently there are like 18.8 billion devices connected. 57% are almost vulnerable to attack. You know, we already have a bright attacker within us. 98% traffic is what unencrypted. So this is what, these stats are coming from the environment, what we look at on the day-to-day basis. And yeah, this is a market. So uh, what makes this unique, in the physical dimension? These devices are deployed in factories, hospitals, buildings, vehicles, and remote sites, often in publicly accessible location with no IT staff nearby. Okay, so there are cases where they may run like, they are running for 10 to 20 years on the same firm where they can, they often cannot be patched remotely. They may have constrained hardware, a small microcontroller, and kilo KBs or RAM, not a server. So scaling is also a challenge. An enterprise might have like hundreds of thousands of devices, each one a potential entry point into your Azure environment. So whenever there is an entry to your Azure environment, it means like, there might be also a lateral movement happening to other subscriptions or, other connected tenants. Okay, so it leads to a complete compromise, and we kind of face that on the very daily basis. So what are the Azure IoT services? From there, what we are going to start. So Azure has like a layered ecosystem of IoT services, and it helps to understand what each one does before talking about securing them. Okay, so uh, okay, let's start with the Azure IoT Hub. It is like a central message broker. All D2C telemetry and C2D commands um, go through it. Okay, think of it as a air traffic control for your fleet. The device provisioning service DPS solves the onboarding problem at scale instead of manually registering every device. Okay, DPS lets devices self-register using group enrollments, and uh, then assigns them to the right IoT hub automatically. Then about Azure IoT Edge, it's like it runs Azure modules locally on the gateway device. Uh, it reduces latency, and it enables like offline scenarios. Then Azure Sphere is something Microsoft end-to-end secure hardware platform. So it is like it has like Silicon OS and cloud service core designed for security. So um, let's assume, not every deployment needs all of these. Most enterprise IoT starts with IoT Hub plus DPS only. Okay. Edge and Spear are like, they add a lot of complexity. So um, understanding, you should have the understanding before, even using them or adopting them going further. Then let's start, let's try to understand how a device connects to a IoT, Azure IoT hub. So here you can see the full journey from power on to telemetry. Okay, so the step one is device powers on. Okay, then it contacts the DPS to register. Then DPS validates the identity. Okay, so here what happens on the step one, the device boots and loads its pre-provisioned credentials. Okay, either a private key stored in the TPM chip or a SAS token in the secure storage. Then step two is like it contacts the DPS global endpoint, okay, which is hosted by the DPS we saw earlier. Uh, Step three is like the DPS checks the device identity against its enrollment group, and four is again like if a valid DPS returns the IoT hub host name, the device should connect to. And then five is like the device opens a persistent TLS connection to its assigned hub on port 883 MQTT and begins sending the telemetry. Okay, so Here, the critical security movement is like on the step three. If a device can pass that check without valid identity, for example, because um, cert validation is disabled. Okay, let's assume. Okay, if the cert validation is disabled on the DPS validate identity, it can impersonate any device in the fleet. Okay, that is the spoofing threat in Stride, which we'll cover shortly. Okay, so you can see uh, okay, so DPS kind of it has a big responsibility in this case to do the validations, and this is one of the common mistake which happens where the certificates can be spoofed it because the default configuration is set to like no valid or invalid, something like that. So the certification bypass happens here. The identity can be spoofed here. Okay. So again, the four-layer Azure architecture here. Okay, so these has like four distinct layer. Each one has its own attack surface. So understanding the layer is essential for threat modeling. Uh, that is what I do on the daily basis for this ecosystem. So the device layer is kind of the physical hardware, microcontroller, sensors, embedded, Linux boards, and attacks here are kind of physical firmware extraction, debug port access, side channel attacks. Okay. Then comes the edge layer. Edge layer is kind of the gateway or on-premise compute running IoT edge. Okay. Then there is a network layer, is like communication part, typically cellular, Wi-Fi, Ethernet, and the last one is the the device layer. The uh, okay, so the cloud layer, sorry, is IoT hub, DPS, storage, analytics, and all downstream devices. Okay, the last one. So one of the key insights from the real world IoT breaches is that, like, attackers rarely stop at the device. They use the device as a stone into the cloud environment. So that uh, device to cloud pivot is the central theme of the part two. So uh, so that is what we are going to do in the second version of the part two, where we'll see how exactly each layer is going to be attacked. Now, why IoT security is not, you know, not the traditional IT security? Because you see the patching, the lifespan, physical access, resources, OS, network agent, scale, ownership, everything. It's very different than the traditional IT. Patching on the traditional IT systems, it's easy, click to update, but on the IoT devices, it's hard and impossible remotely. Okay, the lifespan you can see it's different. There are a lot of challenges over here, right? So uh, so these constraints means we cannot rely on the same controls we use in IT security. We need to design security in from the start, not bolt it on later, right? So that's what we are trying to do as a part of this series. So this is about the CI triad, which can be applied to IoT. So if any one of you is not aware of this CIA, then it's pretty simple. Confidentiality, only authorized party can read your data. Integrity, data has not been tampered, and availability is about systems are accessible whenever they are needed. Okay, so under confidentiality, um, in IoT, like that PLS on all devices connections, encrypted storage for sensitive telemetry, and access control on the event hub and downstream services. That should be there. Uh, the failure mode is unencrypted. A lot of times it happens. MQTT on port 1883. Everything is readable on anyone on the same network. It happens. Then on the integrity part, so it means like signed firmware updates, validated message schemas, and audit logs. The failure mode is a man in the middle attack and modifies the temperature. These are simple attacks where uh, the sensors are modified. The temperature is changed, triggering a false emergency. These kind of attacks happen. Then the availability, um, where rate limiting on the IoT hub, DDoS protection, per device quotas. The failure mode is like a single rogue device flooding the hub with millions of messages, denying service to entire fleet. That's you know that's the availability part. So any one of you, I'll just take a pause here. Uh, because I'm pretty curious. I was looking at the participants here. Any one of you working on any of the such devices which are connected to the Azure, especially Azure, because there are some other constraints with the AWS as well when the IoT devices are connected. But Azure is something very interesting for me because I'm part of it. A lot of services related to this are developed on the day-to-day basis, and we review them. So any one of you came across, um, I know most of you might have been already working on the IoT side of the hacking part, but any one of you were able to pivot the attack to the Azure environment. Was that done by any one of you? Maybe you can provide some insight. No, Arun? Okay, okay, let's move. So now authentication. Let's start with some of the basic part. Okay, device authentication. Most of the Azure devices, they use SAS tokens or certificates for the authentication. So in this case, um, it it basically has to know, like, IoT hub has to know which device who it claims to be, right? So there are like these two known mechanisms. A lot of them use because they are very easy to understand and implement. Okay, any one of you have came across SAS tokens, shared access signatures? These are simple, a time limited HMAC SHA-256 signed string. Okay, it's very easy to implement, works on any hardware, but again, there are risks related to this. So the underlying shared key must be stored on the device. Okay, tokens expire, causing the connection drops if rotation is not automated. So it is like a single token. Lot of them, store on the device unencrypted or, in a unsafe storage, I would say, which can be easily or hard code them within the firmware somewhere. That can be uh, be easily found. Okay, and the stolen token, again, it's valid until it expires straight away. Okay, then the certificates. Um, These are like the production standard. Each device gets a unique certificate signed by your CA, stored in a TPM or secure element, any other secure elements. Okay, the private key never leaves the hardware. Certificates can be revoked instantly through IoT's hub device registry. Okay, so this is a recommended approach for any production deployment. The DPS service. So DPS service supports both. Now, if you're starting fresh, I would suggest to use X.509 group enrollments from day one. Okay. SAS tokens are acceptable for development, but development and testing is okay with the SAS token, but you should never go to the production for live, long-lived devices, because in that case you have to keep the SAS token, create the SAS tokens with long live, expiry. It should not expire. And if it is stolen, then, your device is gone. basically. So the connection part, the transport security, TLS in Azure IoT. So this is non-negotiable for Azure IoT usually. Okay, every Azure IoT device, IoT hub, DPS, edge, it requires TLS. So if you're thinking about the IoT device connecting to the Azure hub, but even these services, even these services internally, they have to be connected securely, right? So uh, but what happens? There are many ways. There are ways like team accidentally break its protection. It happens. The most common failure is like, the certificate validation, the disabling the certificate validation. So a developer adds something like, SSL cert none, that's gone. Okay. Or verify false to get past a TLS error quickly, and it stays in production forever. And these completely defeats TLS. So the device will accept any certificate, meaning any attacker on the network can intercept and modify all traffic. Okay. And the second failure is like using the legacy version, like, TLS 1.0, 1.1, or there are a lot of SSL versions also with the known attacks like Poodle Beast. Now any script kiddies, nowadays, if they find these, they just run attacks right away. Third failure is like the expired certificates. If you do not automate certificate rotation, devices start failing connecting connections when certificates is expired. So this is availability failure that is entirely preventable. So I remember, there was one product, they were having like 5,000 devices connected. And I will tell you what stupidity those guys did. Um, they their certificates were going to expire like within couple of months, and due to like internal bureaucracy, like how to update them, and these and that, and the threat modeling and all these SDL related practices, they were not able to roll out the automated part. They were not able to update the certificates, and after 2 months on the same day, like all these 5,000 devices went down. Okay. And so they they were not able to update those certificates for another, let's say, a week, and all those devices were shut down. Just imagine, these were medical devices for big hospitals. So they literally, these people, they rushed to the hospitals, they manually patched it, updated the certificates. Okay. So um, these kind of things happen when people are not aware, the development and teams are not aware what's happening. So there should be some kind of automation in place in that case to check how the certificate validity on day-to-day basis. So key message, TLS one is not enough. TLS correctly configured is what matters. Okay. Then authorization, this is a very one of the important part. Who can do what in Azure IoT? So authentication tells you like who a device is, but authorization actually tells you what it is allowed to do. So these are two very separate controls, and many teams conflate them. So at the device level, each device's credential only grants access to its own MQTT topics, right? So its own telemetry channel, its own device, its own device twins, its own commands, okay, all those things. So devices cannot access each other's data by design. This is a good isolation that is provided on the Azure side, okay? So at the service level, backend services authenticate using shared access policies. Okay. So the dangerous one is IoT hub owner. Okay. I'm not sure how many of you have seen that, but okay. If you see, there are like different, um, if someone of you might have already configured Azure services, you should be aware like, okay, to these terminologies, contributor, reader, owner. So these kind of shared access policy, these kind of policies RBAC policies, you can the rules are created and you can configure them. Okay, so what happens if you use IoT Hub owner? It grants full access to everything. So teams kind of reach for this because it is very easy. It is very easy to implement, but it violates least privilege. So what you have to do, you have to use minimum policy, whatever your service needs, right? So what is the modern approach? Nowadays, it's like using RBAC with Entra ID roles. Okay. So for example, IoT hub data contributor, data reader, registry contributor. So these support like conditional access. And if you want something, if you want to elevate your access, use PIM, privilege identity management. So PIM for just-in-time access and get full audit logging and full access to the service. Then come back to the least privilege. Okay. So now, if you are building a new backend service, use RBAC, not shared access policies. Okay. So at any point of time, the principle of least privilege is the key message here. Every identity, device, service user should have only the minimum permissions needed and nothing more. That has to be followed. So the next is device identity lifecycle. So from the factory floor to the end of life. Okay, every stage has security implications. So uh, manufacturing, this is where identity is born. The device gets its unique, let's say X.509 certificate injected. Then the private key is sealed in the TPM. Okay, this should happen in the secure manufacturing environment. So if the key generation happens in the open, the identity is compromised from the birth. Then first boot registration. The device contacts DPS for the first time. The claim is validated and a hub is assigned. Okay. Security teams should monitor for unexpected first boot events. So from devices that were not supposed to ship it. Okay. Then what is operational maintenance? This is the longest phase, potentially years. So certificate rotations, firmware update, patching, and whatever the suspicious behavior is happening, it must trigger alerts. Um, and the compromise incident. If a device is stolen, compromised, the response must be immediate. So revoke the certificate in IoT Hub, disable the device, rotate any shared credentials, investigate the blast radius. That's the stage four. Then end of life. How many of you, how many of you have like, uh, consider this as a, I would say, non-essential step because there are a lot of teams I have seen the decommissioning process is not not properly done. Now we came across an incident where the medical devices were not decommissioned properly and it was holding a lot of PHI data and it was used to pivot attack to to the Azure environment. So the device was kind of sitting in a recycle bin with a valid certificate with all the security risk. So this is step very essential, but people tend to ignore this step. Okay, so what are the common mistakes? Hard-coded credentials in firmware. I'm sure, like, this is the basic thing. This is the first step, kind of a lot of people look for when they do the firmware, extraction. Okay. Uh, what to do instead? Use TPM, secure elements, store private keys in hardware where they cannot be read out without, they cannot be accessed physically. Um, Then use DPS with individual enrollment. So each device has a unique revocable identity. Okay, and read credential from secure storage. I would not say here it is written like if SAS is used, but I would definitely not go for the SAS tokens because even if you're using set expiry to 15 to 60 minutes max and rotate automatically, come up with some system for doing it. Okay. um, Second mistake, unencrypted communication. The common patterns are like MQTT on port 183, plain text, all messages visible to anyone on the network. Um, it happens uh, because developers, they need to quickly look at the connect the things to the to the environment. They tend to skip these steps, configuring it properly, and the TLS validation, even if they do the TLS validation, they keep it off, over the pattern we discussed on the previous slide, right? So the traffic looks encrypted, but the device will accept a self-signed certificate from the attacker's proxy. So that is worse, like this than no TLS in some ways, because it creates a false confidence for the users. So again, you should go ahead and enforce at least minimum TLS 1.2, which is again not secure, but at least go with that for now. On IoT Hub, um, this can be set in the IoT Hub resource configuration, and you can block any device attempting to connect with a weaker version. Add this to your deployment checklist, and automate the check with the Azure policy. So Azure policy is again, another way of I would say controlling all the services which are there in the Azure, in your Azure environment. Mistake three, excessive cloud permissions. We talked about it. Like, uh, so what is the classic pattern? A developer needs to test something quickly. He uses IoT hub owner connection string, and it ends up in the production application. So IoT hub owner, like we discussed, has a full access. It can read all devices, send command to any device, delete any device. It can do anything. So one leaked IoT hub owner, key gives an attacker complete control over your entire IoT fleet. Okay. Another common pattern is like the same key is used for by both devices and the backend service. So let's say if a device is compromised and its key is extracted, the attacker knows now has like service level access, not just device level access. Okay. In this case, the fix is very straightforward. Uh, Create purpose-specific policies. A device that only sends telemetry should have a policy with only device connect permission. Okay. A service that reads, should have only like registry read kind of permission, rotate credentials on schedule, um, and treat like any IoT hub key like a production database password. Store it in key vault, not in configuration files, or not in the environment variables at all. Next is insecure firmware and OT updates. So this is again a common pattern where uh, secure boot means like the device checks a cryptographic signature on the firmware before executing it. But without secure boot, an attacker with like, physical access can flash any firmware onto the device, right? So including a backdoor version um, that looks identical to the legitimate one, uh, but but it can exfiltrate data or provide remote access. So this modified firmware survives factory resets basically. So uh, another one is like, OTA over the air updates must be signed and delivered over TLS. If OTA package is unsigned, an attacker who can intercept the update channel, it can like, the man in the middle on the device's network. So they can serve a malicious framework image to the entire fleet. Okay. Then, uh, so uh, if you remember, we were talking about the Azure Sphere service, right? So let's say Azure device updates for the IoT hub, addresses the delivery problem. Azure Sphere, actually one of the service, it can address the secure boot problem by, co-designing the Silicon OS and update service. Okay, that's one of the service you can take a look at. So, but for the team who are not able to use Sphere the um, because of the costing, definitely these Azure services, they are sometimes they come with the cost. So what you can do is at minimum you can sign your firmware packages and verify the signature on the device before applying it. So this should be non-negotiable for at least for the medical industry. So because any of these critical deployments, they can be at the risk. Okay. No monitoring and alerting. I know this is a very common mistake we come across because a lot of organization they say like, okay, monitoring, alerting, it's like a cost consumption for them. So either they go with the only with the audit logs, but there is not alerting. So again the level of logs which they enable, it's like very minimal, but in this case you should enable some diagnostics logs. So you should have record of which devices are connected, what kind of errors you are getting from those devices, all those things, and that should be going to the log analytics. So you should send all the logs to the log analytics, and you may be you may be aware of the Defender service. It should be enabled. Again, it comes with the cost, but there are again some free tier which provides some kind of support, which can auto detect the common attack patterns. And then everything should be connected to the Sentinel. Like it kind of centralizes your IoT alerts. So you can write your own playbooks. You can edit those playbooks to make sure based on the whatever the attacks are happening, whatever the errors you're getting, everything you will get. All the alerts will be shared with you. So okay, so Stride, how you can think about the attacks? Basically, you can use Stride, spoofing, tampering, repudiation, information disclosure, DOS, and elevation of privilege. Okay, so okay, so these are the some of the security services for IoT, kind of a different toolkit, I would say. You should be aware of and should be using it. So the one I already mentioned, Microsoft Defender for IoT. So it is like an agentless passive monitoring service. It mirrors network traffic from a tap or span port, okay, and uses behavioral analytics to like detect rogue devices, lateral movements, and known IoT attack patterns. Okay, it does not require any changes to devices. This is a free tier for cloud connected IoT hub environments. This should be one of the first thing you should enable. Okay. Then Key Vault, you can securely store all the credentials. No need to store anything into the storages. You can retrieve, rotate. You can do certain sort of automations with it. Okay. Your certifications will be signed by the CA. Everything can be taken care by the Key Vault. Then Azure Sphere. Um, so So we talked about this. This is like, hardened IoT OS, secure chip combo from Microsoft. Okay, it has built-in secure boot, certificate-based authentication, automatic OS updates, everything, are readily provided by the Microsoft. Okay, Azure Sphere, but it comes with the cost. So yeah. Um, Then the Microsoft Sentinel. So this is like a cloud native SIM. It's very famous, which can ingest all the kind of alerts from the Defender, from the different services. It provides you the SOAR automation. It can automatically, quarantine a compromised device when Defender triggers an alert. And, it has like pre-built IoT threat detection rules, which you can like, even you can draft your own playbook to do the job on the Microsoft Sentinel. Then there are like Azure Monitor, Log Analytics, Microsoft Entra ID, which is very important. So You should use Enter ID instead of shared access policies for IoT Hub. Um, the management plane. I hope you guys know what is management plane, what is control plane. So it comes with the support of MFA, conditional access, PIM, everything. Everything is in place. Okay. So directly jump to the quick win for the security checklist. Okay, if you are maintaining such an environment, do it today, which are like free. Um, so these checks you can do it on your own. Should not be cost consuming or anything. You should enable the hub diagnostics logs, send it to the log analytics. Check the minimum TLS version, which is there on the IoT hub. Enable the defender, uh, audit shared access policies, delete anything you don't need, anything you don't understand, delete it. Okay. Verify like no IoT hub keys are there in the GitHub ADO repositories. I hope now you guys can use a lot of uh, cloud related skills in order to scan your repositories for this. Then set device to SAS token expiry. If it is really not that dependent, like let's say if your device is continuously connected, maybe you can write some kind of automation where the SAS tokens will be automatically rotated. Okay. Then do this week. Within a week, you should move all your IoT hub keys to the key vault with the rotation policies. Enable IP filters, restrict the known devices IP ranges only. Um, Obviously, review your IoT Edge module images. Um, so basically, this week, it's it depends. The week section is like it is more on planning. Migrate any SaaS based authentication to certificates, implement certificates, rotation automation, implement OTA, firmware signing, enable Azure policy assignments for IoT. Okay, and plan for the next quarter is again like deeper architectural work, I would say, deploying Defender for IoT sensors, implementing network micro segmentation. So these kind of things we are going to do in our next sessions, where actual will come up with with some scenarios where these controls are not there and what kind of attacks will happen on each layer. Okay, so okay, I have put I have given some Microsoft Learning resources, standards and frameworks. If you want to do some hands-on, you can. I have just put all the resources here. And if you're planning for any certification path, those details are like, I have included in the slides, which I will share after this. Okay. So yeah, that's it for now. So let's hope part 2 and 3 goes well. Any questions before we stop? Okay, no questions.
Yes. Thank you, Aditya,
Right.
and thank you so much for keeping allow yourself till now.
No
So
problem.
I
Yeah.
think so. There is one question I would like to check.
Yeah.
When I think of IoT, the first time comes into mind is Shodan.io. I want to know what are the misconfiguration are there which makes an IoT device indexable by Shodan or others. Is there any counterpart in AWS or Google in this case?
Uh, for now, on the indexing part, I don't think so. There is any on the cloud side. Maybe Arun, you might know better on the indexing. part how we can control on the
Yeah.
IoT side.
Yes, yes. So generally, when we talk about IoT, so if IoT based on the microprocessor, so the microprocessor have Linux environment, very minimalistic Linux inside.
Mm,
So there are a lot of highly chances that there are some ports which can be open. For example, we can take an example. If you Google that Mirai botnet,
mhm,
Mirai botnet is like you know. It search for default credential, default not default ports. The ports are activated like
mm,
telnet or any kind of from where they can change the firmwares. So like that, the indexing is based on the ports and which ports have vulnerable ports, I mean to say, or rather we can say
mm,
ports which can accept default credential. That's how entire Mirai botnet was there. It generally
mhm,
they change the firmware in such a way, and then again they are going to use for DDoS attack, distributed
mm,
denial of service attack. So that's how the shutdown works as well. In this case, it scans the entire internet, and after that, based on the banner grabbing, they came to know that these are the IP camera or any sort of home appliance, and because of that port number, they can understand which OS they can use with a
mm,
specific scan, and they list in the indexing. So
mm,
with respect to MQ, with respect to, I would say, uh, with respect to MQTT, there would be a if the MQTT is not secure, like 2.0 or 2.1.2 or 1.3, so definitely there would be highly chances that it's going to be compromised between the communication from the device, the IoT device, and the cloud in this case. So
yeah.
yes, in this basis, yes. But I don't know about the how it's going to list any kind of that particular cloud with specific to the OT device. I think so.
Mm.
Uh,
So
that
yeah,
I think so. Aditya can clear that thing. Yeah.
yeah. So the IoT, when you say Azure IoT, specific risk, right? So IoT Edge Gateway, I would say the IoT Hub itself is not Shodan indexable. Okay, so uh, because the reason is Microsoft kind of owns and secures those endpoints. So the risk is on really on the IoT side. So usually what happens, IoT Edge Gateway, like with the management port, 4435671, I think. So those are exposed without firewall. It happens. Then, like Arun mentioned, the MQTT, like on the on-premise MQTT broker acting as a bridge with port 1833. If those are open, not properly configured, those get indexed and those get exposed. Uh, so Yeah, so on the cloud side, that's pretty much secure, right? So it doesn't get indexed. So similarly, it goes with the AWS and Google Cloud or any cloud equivalent service provider. It happens. So most of the security command centers, they check for, usually the active checks are also going on. Like they look for their own publicly exposed services, like we were talking about the Azure Defender, right? So Google or AWS, they have their own equivalent cloud internet facing detection endpoints. They actively scan those if something is listed by Shodan or Natless, Binary Edge. There are like a lot of different services, right? Uh, those are like uh, they catch them, they secure them, or just close it down. It happens. Yeah, I hope I answered your question. Uh, Hemant. Okay, cool.
Yes, I think
Thank
so.
you. It
Yeah.
was a nice, yeah, it was a nice session.
Thank you so much, Aditya, for your time and uh, having such a patience from one session to till here. And thank you so much, everyone, in the specific this time of the Saturday. You guys still are here and listening and watching the talks. This contributions also comes from you as well, not only from us. And I'm really happy that we are delivering such a nice talks actually, and even in the future we will plan like we are going to change some sort of uh, some sort of strategy. So as we discussed with Surmit and the Paul and everyone actually, so that we will come with 1 hour or 1.5 hours, any Saturday we'll have a workshop actually in this case. So then it will help to everyone in this case that they can enjoy. So thank you so much, guys. Thank you all speaker, Mr. Paul, Surmit and Ved and Aditya. Thank you so much, and thank you myself. Just kidding. So thank you so much. Yeah.